Matplotlib, and Seaborn. These are the most used libraries in Python for data visualization purposes. On one side, we have Matplotlib, which will allow you much more customization in your plots, but the downside is it will bring much more complexity because of that flexibility of customization. On the other side, we have Seaborn library, which is built on top of Matplotlib, which allows you to plot much more appealing plots with very less code. And that's why generally beginners prefer Seaborn over Matplotlib, because they don't have to take much effort to plot the same plot in Seaborn as compared to Matplotlib. In this video, we'll see how we can plot boxplot using both Matplotlib and Seaborn library, so that you can also compare the different libraries together. So let's jump on to our Google Colab and let's see how it can be done. Okay, so now we are in our Google Colab environment. The first thing that we need to do is to import our basic libraries. So I will be importing two libraries. One is NumPy and another one is Pandas library. I just execute this statement. The next thing that I need to do is I need to read the data on which I will be plotting the box plots. So for data, I will be storing it in a variable df, and I am using pd.readcsv command where it reads the CSV file. You can download this CSV file from the video description below and just paste it in your environment as well, so that you can also copy the name just like what I'm doing now and paste it here. And if I just run this, my data is imported, so that you can also learn with me together. All right. So we have our data set stored in df variable. Now, once we have our data set, let me just quickly show you what the data set contains. So for that, I'm using df.head command. It just samples top 5 values for me. And you can actually see that the data set contains information about the passengers who boarded the Titanic. So it contains information like the passenger ID, if the passenger survived or not, the ticket class on which the passenger was traveling, the name of the passenger, the sex, age, and other informations. Okay, so you don't need to know everything in detail. You just keep in mind that we have such kind of data set inside our df variable. All right, now once we have imported our data set, in this tutorial, as we already mentioned, that I will be showing you how you can plot boxplot using pyplot, which is a module from Matplotlib, and boxplots using Seaborn. So first, let us start with the pyplot module. So in order to import the pyplot module, you can just say import matplotlib.pyplot as plt. So our pyplot module is imported. Now to start with, to just plot a basic boxplot, you first need to define which variable you're going to plot the boxplot on. All right. So let me just take one column from my whole data frame. So if you see, we can take this age column, which contains age of all the passengers traveling on the Titanic. So I just take that column and store it in my variable var. All right. Now I can use this variable to plot my boxplot. For that, I just need to do plt.boxplot and then write in the variable name. Now, if you see the documentation of boxplots in Matplotlib, you'll see various options that are available. But in the interest of time, I'll not be showing all the options. I'll be just showing the important options that you need to know, and which will also be helpful to you in order to make your own boxplots whenever you are working on your data set. All right. So the most basic thing that you can do is say plt.boxplot and write your variable name. And now if I run it, you'll see we don't have any boxplot. Why is that so? Because in the age column, we have some null values as well. And if we have some null values in the data set, the plt.boxplot command will not run. For that, you have to first drop your null values. So you can use .dropNA method in Pandas. Now, if you're very new to Pandas, I have another video. You can click on that video link later after this video, and you can watch where I have covered everything related to Pandas and how you can handle and visualize your data set using Pandas library. Okay, so you can use this .dropNA method from Pandas to drop your null values, and once you drop those values, the new variable will be able to be used for my box plot. You see, now we have our box plot ready. Very new to boxplot, again, I would highly recommend you to watch my another video where I have already covered from very basics to everything you need to know about boxplots. If you already know about boxplot, we can go ahead. So just a quick recap, in boxplot you'll find a box as obvious. So the box contains the first quartile and the third quartile range. And in the middle of, not in the middle, but in between these two lines, there is a orange line that you can see, which is the median. Now, apart from this box, we also have whiskers, which extend on both sides of this box. And the length of this whiskers depends on the interquartile range. This interquartile range is nothing but the difference between my third and the first quartile. Now, this interquartile range is multiplied by some factor, which by default is 1.5. And then that value is used as my whisker length or maximum point if there is any, whichever is smaller. Alright, so in this we have 1.5 as our factor, and when we use 1.5 as our multiplication factor, it is also called Tukey's definition for box plots. Of course, we can change it based on our biases in our distribution. Alright. So now we know how we can plot a simple box plot. Let's see if I want to rotate this box plot and plot a horizontal box plot. For that, again, I'll write plt.boxplot, the variable name. And the next thing that I can use an option called vert. Vert simply means vertical. So by default, it's true. And if I just change it to false, it will just give me a horizontal box plot. That's it. Let's see what other options we have. Now let's say I want to plot multiple plots now. Instead of plotting a single variable, I want to plot multiple variables and compare their distribution against each other. So let me just define two variables for that first. So variable 1 and variable 2. In variable 1, I will be again using my age column. And if I just paste it here, this is my variable 1, and in variable 2, let me take the fare column. Now the fare column, which is right here, represents the price of the ticket that people paid to board the Titanic ship. So these will be our two variables, and if I say variable 1 and variable 2, and if I just put them in a bracket so that they will be inputted as an array. Now if I just run this, you will see we have two box plots with us. One is for the age, one is for the fare, but we don't have any labels yet. And now for that, you can add labels using the labels command. If it was a Seaborn library, you don't need to do that. It was done automatically. But in Matplotlib, we have to define our labels as well. So that's one difference you notice. So if I just run this, you will see we have our labels ready. Now I know this is the upper one is the distribution for fare price and the lower one is the distribution for age of the people who were on the ship. Alright, but if you see their distribution is very varying. Alright, so what I can do as another option is to plot them on different axes. Alright, so that they have the different ranges. So for that, if I need to plot, so the first method that I showed you was how to plot on single axis. Now, if I need to do the same thing on multiple axes, you can simply type in figure, comma, you have to define two axes, ax1 and ax2, and then I can use plt.subplots function, and this I have already covered in the previous part of the series, and you can just refer that if you are not sure how the subplots actually work. So if I write plt.subplots, it will give me a figure object and an axis object. And if inside these bracket, I define, let's say 1, 2, it knows that the number of axes will be 1 into 2. Alright. So 1, 2 represents that it should be in the format of 1 row and 2 columns. Think of it as a matrix. Alright. So if I do this, let me just run this now. Just to show you this, these two axes are now shown in the way that we have kind of 2 columns and only 1 row in this matrix of axes. Alright. But I don't want to do that. I want to have 2 rows and 1 column. That is, I want to show them upside down, not upside down, but below each other. So this is how it should look like. Okay. Now we have our axes defined. Now I can use this axis to plot my box plot. So if I was using plt.boxplot, it simply means that whatever axis is by default, it will use that. But since I have defined that my own axis, I can use my own axis. All right. And now in this, I can define variable 1. Again, vertical equal to false. I want it horizontal, and I'll just say labels for the first variable, which is a age variable, as age. And similarly, I can do it for second axis. So I'm saying on the second axis, plot the second variable with the label as where. All right. Now, if you see, it's way better than the previous case, because now what's happening is we have different range for our axis depending on whatever the distribution of our data is. So that is how you can plot your variables, multiple box plots in the same figure window. Okay, so this is the same figure window containing 2 axes. Okay, let's move forward and let's see what other options do we have. So I'll just copy this command so that you can see what all I'm actually modifying from the basic command. So the next thing that I can do is to show the means value or the flyers. So if I want to show the means value, I can simply say show means equal to 2. So if I do this, you'll see we have a green arrow which shows the mean value of our distribution. Remember, this orange line is not the mean value, it's the median line, and the green arrow is now showing me the mean value. Now we need sometimes to know what mean value is to recognize the skewness in our distribution. So there are different skewed distributions possible. It could be positively skewed, negatively skewed, or normally distributed. So depending on whatever is the mean value as compared to median value, we can compare those values if it's larger or smaller, and we can decide if the distribution is a positively or negatively skewed distribution. All right. So let me move on. And what are flyers? So flyers are the points which are not counted in the distributions. So these are also the suspected outliers, we could say, and these could also be removed by setting my show flyers option as false. So by default it's 2, you can see that. And now if I do it false, you can see we are not being shown any flyers or suspected outliers in our plot. But I will keep them for our tutorial's sake. So the next thing that we can do is, so this is our basic command, and the next thing that we can do is to add the notch. So for that, if I just run it, you'll understand it yourself. If I say notch equal to true, it will just create a notch on that median line just for better visual appearance. All right, and nothing more. So this also you can do. The next thing that you can do is to change the whisker length that I already talked before. So whisker length by default is 1.5 times the interquartile range. But if I, let's say, change it to 2.5 times, so for that I need to use the option whis equal to 2.5. So it's the factor and not the absolute length. And if I run this, you'll see the difference. You see, the length has spanned up till the maximum value. All right. If I just reduce it to some 2.25, let's say, you can see we have one flyer only, which is this one. And up till that, this point is covered by our whisker length because I have increased my conversion factor or the multiplication factor. All right. So that's how you can increase your whisker length. The next thing that you can do is to change the width of your box. So for that, I can just say width equal to 0.2. Remember this S, it's not width. And now you can see this is the width. And if I just do it to 2, it will increase drastically. Okay. This doesn't look good. So let me keep it to 0.2. All right. So now we also know how to change the width of the box. Then we have the next set of properties that we can change regarding the flyer, box, whisker, and cap. So you already know about flyer, box, whisker. What are caps? So caps are these lines that are drawn on the boundary of our whiskers. All right. So let's see how we can change that. Okay. So in order to change that, we have to define dictionaries for each of those components. So let's say for flyer, I can define a name, let's say flyer prop, which is my dictionary, and I can define various options inside this. Now, once I have the dictionary, I can just say plt.boxplot again. And in this, I have an option for flyer props. And here I can assign my dictionary that I have defined. Now, what is the purpose of this dictionary? This dictionary contains the different options that we can change regarding the flyers or the markers that are there outside our whiskers. So, for example, let me just show you the type of marker that I need. Let's say it should be a cross symbol. Then the marker face color that I need, I can define to be as red. So let us try this and see what it changes. So now you see we have a cross sign and there's no marker face color shown because there's no face. All right, let me just change it. And what if I just do capital X and now run it? Okay, if I do capital X, it will show me the solid cross, and now it has red color inside it. All right, so that's how you can change the flyer properties, and similarly you can do that for other components as well. So I can just change the name and tweak that a little bit. So that's boxplot. I can provide it here. Then this option name is always boxplots. It is defined, you can change that, but this name you can always decide on your own. Now for box we don't have any markers, so I'll just use line width and say, let's say it's to be equal to 2. Let me see. So yeah, now the line width of the box changes. Also, I don't need to plot it every time. I will just show you how you can do it in one go. So similarly, just to show you, let me just say for whisker prop as well, the same thing. So I do whisker props, and similarly for cap. So quickly just change to cap prop, and now I'll just do cap props here. And now for every option I'll be using line width just to show you that it takes effects. And also, as I already told before, you don't need to define the box plot every time. So at the end only, I'll be just providing all the options in my single command. Okay, that's how you can control each of the properties of each of the component properties, and that's the level of customization Matplotlib provides. And now if I just run this, you'll see the line width for box, whiskers, and the cap also changes. All right, and you can also see the changes in flyer properties. Okay, the last thing that we need to know about Matplotlib library is how we can change the face color of the box. So right now it's always transparent. In order to change the face color, you can again copy this first. So this will just plot my box plot horizontally, and now I can say patch artist equal to true. Now what it will do is it will tell the box plot that my box plot should have a solid patch inside of it. So if I just run it, you see it has a patch. All right, now you can also change the color of this patch. For that you need to do something involved. So let me just show you what this BP object contains. So it's actually a dictionary which contains different keys for whiskers, for caps, for boxes, and so on. But I will only be needing the boxes part because I need to fill that part. So I'll just take boxes, and I'll have to take the first component of it because there are different components involved in this particular dictionary. So I just take the first component, and then on the first component I say set face color as orange, let's say. Now there is a list of colors that you can refer to in your dictionary and in your documentation, and you can choose whatever color you like. So I have just selected orange. You can select any color that you like, which is already available in the documentation. So that's how you can change the face color of your box plot in Matplotlib. So that's it for Matplotlib. Let's move on to the Seaborn library. Now let's move on to Seaborn, and now when we will be implementing our boxplot in Seaborn, you will be actually seeing the difference as compared to Matplotlib. Alright, so first thing first, we need to import our Seaborn library. I'll import it as Seaborn as SNS. Now the library is imported. Let's start plotting our box plot. So I will say sns.boxplot, and now I don't need to define the variable by choosing a column. Here I can directly say what's my data. My data is the df where I have stored all the data frame, and the column that I need to pick I can directly put in as my y value as age. So y simply means it will be plotted vertically. Alright, if I just run this, you see it's so simple. Now you can just also change the orientation by, instead of defining y, just say x is equal to age. You can see also the box plot is colored, the axis is labeled, and I don't need to do anything else. Alright, so that's how you can change the orientation of box plot. Then if you would want to include category wise plots, let's say if I just say y equal to age, and on x-axis I want it for every class. So P class is a categorical column, which is the ticket class on which our passengers travel. For every ticket class, what is the age distribution? I can do this simply by writing my y and x component. If I just run this, you see for every ticket class 1, 2 and 3, I have the age distribution, and that's simple. Alright, now I can see the third class people which actually bought the third class ticket, which is a lower price ticket, were generally of younger age as compared to the people who were in the first class. Alright, so that's how I can compare two different variables as well. I can also do the same thing using hue option. Now hue will actually color them based on their values as well. So if I say hue instead of x, it's again plotted on x-axis, but you see we have hue or the color value for each of those categories. Alright, so that's how you can plot categories. Now you also have labels for each categories, and I just need to add this option for that. Alright, the next thing is to change the width. For width, you can simply do width equal to 0.3, I don't know. You can choose any number and it will change your width. It's same as in Matplotlib. For fill color, you'll see again the difference. If I just say color equal to green, just that, it changes to green. Alright, I don't need to change any patch artist value and then set the face color of my box plot. The next thing is to order categories. Now this option is helpful when, let's say, if I was just using hue value to plot my categorical data as well. So if I just paste it here and run it, you see we have our categories shown in the order 1, 2, 3. Let's say I want to change this order. Okay, for that what I can do is I can use hue order command, and then I can say what is the sequence that you want. Let's say I want first second class, then first class, and then third class. Okay, so I want it to compare in this order. So if I run this, let's see. So it is not changed, and that is because this P class column is an object value and not a string value. So I have to first change my column type of P class to string. So for that I can use .s type, and then I can write string here. And now it has string values 1, 2 and 3, and then I can use string values here as well to change the order. You see, now we have the second, first, second, first class, next, and then third class, the last. So that's how you can change your hue order, and you can see your color coding is also changed with it. Okay, if you want to change the palette of colors that you want to use, so you can change that by using option palette. And there are some defined values. You can just refer the documentation for that. For now, I am using spectral palette. You can see the difference in the colors. It has become a little dull or not so bright as compared to before. That's how you can change the color palette for your hue. The next thing that I wanted to show you, if let's say for some data distribution, we have very skewed value. All right. So for ticket fare, you can see that most of the tickets are in between 0 to 100, but there are few tickets which went up till 500 as well. So that's a very skewed data set that you can see here. If you want to make it more uniform, you can change the scale of your fare value and you can change it to log scale by using the option log scale equal to true. Now on y-axis, you see we have values 0, then 10, then 100 and so on. So it's increasing exponentially. And now you can see our box plot looks much better as compared to previous case. So that's how you can use the log scale if needed. So you can see we have various new options in Seaborn and how quickly we can change our box plots using these options. Again, to emphasize, the methods that I've shown you in Matplotlib, the flyer properties, box properties, whisker properties, and cap properties, these are same. You can also use them in Plotly as well. All right. Now, the last thing that I wanted to show you, which is not specifically related to box plot, but it helps you visualize your box plot in a much better way. That's a strip plot. So I'm already copying a snippet of my code where I have already written what's my data, what's my X value, the width of box plot, color, and box props, whisker props that you can use. So you can refer this code later on to see how it changes our box plots. So you can see we have this box plot, but now if I want to show each of the points that contribute to this box plot, for that you can use strip plot and you can see how it works. So I will again use my data as df, my values as age. So it will plot the same points which are used to plot this box plot, but each of those points will be plotted overlapping this box plot. So let me just define my color as, I think it's 0. 0 means complete black, and I'll define my size as 1, let's say, and let's see. So it says invalid argument for color. Is it like this? Right. So now you can see we have all the points which are actually used for plotting our box plot. Let me increase the size of these points so that it looks better. Yeah. So now you can actually see those distribution points. You can see the outliers, the suspected outliers, and how packed they are towards my box. So these are all the options that you can try in Seaborn, and as compared to Matplotlib, you have seen we have a lot less requirement of writing codes to modify our box plot. But in Matplotlib, sometimes it is useful when we need to customize our plots as per our requirements.